Welcome to the mini-lesson on finding the length of a segment. In this lesson, we will review the Cartesian plane and ordered pairs. Then, we will derive the formula for finding the length of a line segment and view a couple of examples to demonstrate the procedure. As we have seen in other lessons, the Cartesian coordinate system, or Cartesian plane, is a map used to graph relationships. Locations on the graph, points, are identified using capital letters of the alphabet. Directions for finding each of these points is given by a code called an ordered pair. The first number in an ordered pair tells you how many units to move in the x direction, and the second number in an ordered pair indicates how many units to move in the y direction. We can connect any two ordered pairs with a line segment, a segment that has length. Finding the length of this segment isn't as simple as counting the number of units that are between the points. However, upon closer examination, the segment in question is the hypotenuse of a right triangle. Let's look at another segment to be sure that this is the case. Again, we can see that the segment in question is, in fact, the hypotenuse of a right triangle. That means that we can use the Pythagorean theorem to determine the length of the line segment. Let's look at this without the use of a grid to help us focus on the information presented in order to derive the distance formula. The vertex of a right triangle would be assigned the ordered pair x2, y1. Therefore, the length of the horizontal axis would be x2 minus x1. The length of the vertical axis would be y2 minus y1. Therefore, the length, according to the Pythagorean theorem of the hypotenuse, the segment between the two ordered pairs, would be the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. That is all we have to remember. Now, let's put this into action by finding the length of a segment when given two endpoints. It makes no difference which ordered pair is considered first. Therefore, let's use the numbers left to right and consider A, x sub 2, y sub 2, and B, x sub 1, y sub 1. The formula, as we have seen, is length is equal to the square root of the sum of the difference of the x-coordinate squared and the difference of the y-coordinate squared. Substituting the values for x and y into the equation, we have that the length of the segment is the square root of 5 minus 2 squared plus 3 minus a negative 4 squared. Simplifying, the length of the segment is equal to the square root of 3 squared plus 7 squared. This is the square root of 9 plus 49, or the square root of 58. The square root of 58 is approximately 7 62/100ths, the length of segment AB. The process is the same no matter what segment we are trying to find the length of. If the endpoints of our segments are points C, 2, -5, and D, 3, 5, we simply use the formula to find the length of segment CD. The length is equal to the square root of the sum of the difference of the x-coordinate squared and the difference of the y-coordinate squared. Substituting x and y values from the ordered pairs, the length of segment CD is equal to the square root of the sum of 2 minus 3 squared and -5 minus 5 squared. This length is equal to the square root of the sum of -1 squared and -10 squared. This is the square root of 1 plus 100, or the square root of 101. The square root of 101 is approximately 10 5/100ths, the length of CD. In order to derive the distance formula and calculate the length of a segment, we needed to review the Cartesian plane and the points contained therein. Based on the Pythagorean theorem, the distance formula can always be figured out if you ever get stuck trying to remember it. Thank you for viewing this lesson on finding the length of a segment. Please join us when we cover other important geometrical concepts in other lessons.